Hello everyone, I'm very excited to introduce our next speaker. Ari is a computer engineering student involved in Python programming while studying data science. Today we are fortunate to hear thoughts about the story of programming while simultaneously discussing the progress and participation of women in coding. This is an important topic and I'm sure that you will find Ari's talk very creative and interesting. Let's give a warm up to our speaker.
Ada Lovelace, born to the poet Lord Byron and Annabella Milbank, carried the weight of parental contradictions. Her father, disinterested in raising a child, abandoned the family early, leaving her mother to steer her future. Determined to shield Ada from Byron's poetic madness, Annabella immersed her in logic and mathematics. Yet Ada's imagination thrived, blending poetry with numbers as she envisioned the analytical engine, a machine capable of computation and creativity. Her brilliance laid the groundwork for modern computing, earning her the title as the first programmer. This is Lovelace's diagram from Note G, the first published computer algorithm. Ada collaborated closely with Charles Babbage, often referred to as the father of the computer. Fascinated by his analytical engine, a mechanical computer, she drew inspiration from the Jacquard loom, which used punched cards to weave intricate patterns. Ada recognized the potential for Babbage's machine to go beyond calculations, envisioning it capable of processing symbols and even creating music. Her detailed notes included the first algorithm intended for a machine, making her the pioneer of programming. This visionary work foreshadowed the versatility of modern computers. The analytical engine, designed by Charles Babbage, was a mechanical computer with features like a CPU, memory, and punched card input. It inspired Ada to pioneer programming and foresee machines processing more than just numbers. The analytical engine might act upon other things besides number, were objects found whose mutual fundamental relations could be expressed by those of the abstract science of operations, and which should also be susceptible of adaptations to the action of the operating notation and mechanism of the engine. Supposing, for instance, that the fundamental relations of pitch sounds in the science of harmony and of musical composition were susceptible of such expression and adaptations, the engine might compose elaborate and scientific pieces of music of any degree of complexity or extent. Humans are allergic to change. They love to say, "We've always done it this way." I try to fight that. That's why I have a clock on my wall that runs counterclockwise. A quote famously said by Grace Hopper. Grace Hopper, an important figure in computing, encountered a literal bug in 1947 when a moth was found stuck in the relay panel of the Harvard Mark II computer. She taped the moth into her logbook, coining the term debugging for fixing computer issues. This incident became a legendary anecdote in the history of computing. She was instrumental in the development of COBOL, a high-level programming language designed for business applications. Unlike machine code, which is difficult for humans to read and understand, COBOL was created to be more intuitive, using English-like syntax. Hopper's vision was to make programming accessible to a wider range of people, greatly influencing the evolution of software development. She served as a Rear Admiral in the US Navy, earning numerous accolades for her groundbreaking work in computing and military service. She was awarded the Defense Distinguished Service Medal, the Navy Distinguished Service Medal, and several other honors throughout her career. In 1906, she was born in New York City. In 1934, she earned a PhD in mathematics from Yale University. In 1943, she joined the US Navy Reserve Waves during World War II. In 1944, she worked on the Harvard Mark I, becoming one of the first computer programmers. In 1947, she coined the term debugging after removing a moth from the Mark II computer. In 1949, she began working on the UNIVAC 1, the first commercial computer. In 1952, she created the A0 compiler, the first compiler revolutionizing programming. In 1959, she played a pivotal role in the development of COBOL, one of the earliest high-level programming languages. In 1969, she was named the first Computer Sciences Man of the Year by the. In 1985, she was promoted to the Rear Admiral in the US Navy. In 1986, she retired from the Navy at 79, receiving the Defense Distinguished Service Medal. In 1991, she was awarded the National Medal of Technology. In 1992, she passed away on January 1 and was buried with full military honors at Arlington National Cemetery. In 2016, posthumously awarded the Presidential Medal of Freedom.
Wish me luck as you wave me goodbye. Cheerio, here I go on my way.
During World War II, women played a critical role in programming, working as computers to calculate ballistics and code-breaking tasks. Despite their contributions, they were often overlooked and worked in challenging conditions with limited recognition or advancement opportunities. Their efforts laid the foundation for modern computing but remained largely unacknowledged for decades.
It's the world's first electronic computer.
What the Army didn't tell the world was that the new machine had been programmed by 6 women mathematicians.
The ENIAC women were pioneering programmers of one of the first electronic computers, tasked with complex calculations during World War II, but initially uncredited for their groundbreaking work. At Bletchley Park, women formed the backbone of cryptography efforts, deciphering enemy codes under intense secrecy, with their contributions proving vital to the war's outcome. The astronaut floating in space is there thanks to the brilliance of women at NASA, whose calculations and innovations made human space travel a reality. Katherine Johnson broke barriers at NASA with her extraordinary mathematical calculations that were crucial to the success of early space missions. At first, she worked in a pool of women performing mathematical calculations. Katherine has referred to the women in the pool as virtual computers who wore skirts. While the racial and gender barriers were always there, Katherine ignored them. Katherine was assertive, asking to be included in editorial meetings where no women had gone before. She simply told the people she had done the work and that she belonged. Her equations in orbital motion were pivotal in calculating flight paths for space missions, including John Glenn's orbital flight. Her precise calculations ensured spacecraft could navigate through complex gravitational forces, helping astronauts reach outer space safely and accurately. Outside NASA's Langley Research Center, a sign now honors Katherine Johnson, celebrating her legacy as a trailblazing mathematician whose calculations were vital to space exploration. Margaret Hamilton once described her work saying, "I was like a systems person who happened to know how to code," emphasizing her unique approach to problem solving. As the lead software engineer for NASA's Apollo program, she created robust error handling systems that saved Apollo 11 during its historic moon landing. When a radar overload threatened to abort the mission, her foresight ensured the software prioritized critical tasks, allowing the astronauts to land safely. Hamilton also coined the term software engineering, advocating for programming to be treated with the same rigor as other engineering disciplines. In 2016, she received the Presidential Medal of Freedom from Barack Obama, honoring her contributions to space exploration and technology. Annie Easley was an African-American computer scientist and mathematician whose work at NASA helped develop software for rocket launches and space missions. She taught herself the programming language Fortran and optimized code for energy conversion systems. In her own words, she said, "Don't give up on it, just stick with it. Don't listen to people who always tell you it's hard and walk away from it." Annie wasn't doing this for the spotlight. As she said, I'm out here to do a job, and I knew I had the ability to do it. And that's where my focus was on getting the job done. I was not intentionally trying to be a pioneer. She stood for diversity through one on one mentoring and outreach, often speaking in classrooms and to community groups. She inspired young women and minorities to pursue careers in STEM, using her own journey to show that barriers could be overcome with determination and education. Thanks to women like Annie Easley, Margaret Hamilton, Katherine Johnson, Frances Northcutt, and countless others at NASA whose expertise and dedication made space exploration possible for us. I would have to include Carol Shaw, who was simply the best programmer of the 6502 and probably one of the best programmers period. In particular, she did the 2600 kernels, the tricky bit that actually gets the picture on the screen for a number of games that she didn't fully do the games for. She was the go-to gal for that sort of stuff. Carol's 3D tic-tac-toe developed for the Atari 2600 in 1978 transformed the classic game into a challenging and futuristic experience. Players competed on a 4x4x4 grid, stacking moves across 3 dimensions to achieve 4 in a row. This innovative gameplay demonstrated Shaw's pioneering design skills and highlighted the potential of video games for more complex strategic interactions. Her other game, River Raid, released in 1982 for the Atari 2600, redefined scrolling shooters with its dynamic gameplay and procedurally generated levels. Players piloted a fighter jet through an ever-changing river landscape, requiring precise control and quick decision-making. She was honored as an industry icon with the Game Developers' Choice Award in recognition of her work and lasting contributions to the video game industry. Rhea Perlman, mother of the internet or not? As one of the few women in her computer science classes, she frequently felt isolated but remained driven to innovate and excel in the field. In an interview, she said that I noticed that it kind of looked weird. This other gender person looking curiously out of place in the crowd. I'd have to remind myself that I was also that other gender. She invented the spanning tree protocol, a breakthrough in network design that ensures data flows efficiently and prevents loops in Ethernet networks. Her work laid the foundation for robust and scalable internet connectivity. She published a poem on this protocol called the Algorithm. I think that I shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First the root must be selected, by ID it is elected. Least cost paths from root are traced. In the tree, these paths are placed. A mesh is made by folks like me, then bridges find a spanning tree. These are some of her words to remember. Life is unfair, it drives me crazy, because I want it to be fair, but obnoxious backstabbing people do well for themselves, while really nice deserving people don't do as well as they should. But this will never change, and you have to not let it bother you too much. The best thing you can do is to try to help other people by mentioning their contributions whenever you get a chance. The second one is, everyone is insecure, especially pompous people. Really smart people are actually sweet and generous. And lastly, it's okay to ask for help. When doing a final exam, all the work must be yours. But in engineering, the point is to get the job done, and people are happy to help. You should be generous with credit, and you should be happy to help others. She consistently rejected being called the mother of the internet, stating that no single person can claim credit for such a vast creation. She views her work, including the invention of the protocol, as one piece of a collaborative puzzle that built the modern internet. Her humility underscores her belief in teamwork and the shared nature of innovation. Now let's find out how are women in programming doing right now.
Assigned projects, I would cry to my mom because I was so frustrated because I wasn't understanding the material, or I would get stuck and not know how to fix it. It was just very bad. I had a really bad experience at first. I would compare myself to people that would be in my groups who had been coding for years, even though they were my age, because they would talk about how easy it was, how
they were passionate about what they were talking about, and I didn't feel the same. So coming back into year 3, into junior year, I really had these doubts about software engineering specifically.
So we don't feel like we fit in, right? And that is why we need each other. Conferences like Pi Ladies, The Rising, and Women in Tech provide a supportive community for women in tech, helping them feel seen, valued, and connected. Today, women make up only 27.6% of the technological workforce, but we've always belonged here, and we're here to stay. These are some of the topmost women in technology, so if they could do it, we can too. Thank you for listening to my presentation, and I hope this will inspire you to work hard in the field of computer.
Thank you very much for this wonderful and creative overview. I love it. To our audience, remember to ask your questions to our speaker in Discord. See you there.